viewers, my name is Mr. Emmanuel, and I'm welcoming you to our channel. Today, we are diving into a series of physics problem-solving tutorials designed specifically for students preparing for the Waec exam. We solved some of the previous year's topic, especially the 2023, that was last year's physics and theory problems. We concentrate on the first three questions in the theory questions, and we'll break it down to the level that you understand. So whether you are looking to brush up on key concepts or seeking strategies to tackle exam questions effectively, you are in the right place. We'll break down complex physics problems into manageable steps, helping you understand the hows and whys of each solution. So grab your notebook and let's get started on mastering these physics challenges together. Don't forget to like, subscribe, and hit the bell icon to stay updated with our educational content. Let's ace this exam together. I'm rooting on you. So let's begin. So Waec 2023 theory, question 1 to question 3. As you can see, the question 1 is on the screen. So the question is, the force F acting on the wings of an aircraft moving through the air of velocity v and density rho is given by the equation that's given, where k is a dimensionless constant and a is the surface area of the wings of the aircraft. Use dimensional analysis to determine the values of x, y, and z. This is a very interesting question. Very interesting. And we'll break this question down so that you will understand it and tackle similar questions that will come your way. So I'll begin by letting us know what dimension is in physics. So in physics, dimension refers to the physical nature of a quantity and is represented by the basic types of units used to measure it. And the basic type of unit we're talking about are the fundamental quantities. So most of the quantities may be derived, but we reduce them into the fundamental quantities or the fundamental units. So, and these fundamental units include mass. The fundamental quantity include mass, length, and time. So these are the fundamental quantities. We have others like electric current. Electric current. We have temperature. Temperature. We also have amount of substance. And luminous intensity. So luminous intensity. All these are fundamental quantities, but we'll be using especially the first three quantities, which are the mass, the length, and time. So in dimensional analysis, we use the initials of these quantities. For example, mass is represented with a letter M in capital letter. Length has a dimension L, and time has a dimension C. So these are the three basic units that we'll be using. Now, having understood what dimension is, now the dimensional analysis has to do with using these quantities, these quantities that we have, to check the consistency of an equation by ensuring that the dimensions, which are the unit of measure of the terms on both sides of the equations, are the same. And this is very, very important because it helps physicists verify that equations are physically meaningful and can also be used to derive relationships between different physical quantities based on their units. So let's get into these. I'll give us some rules. Now, because there are problems that may come that will require you to know these rules. So our next video will stop problems just based on dimensional analysis only, so that you see different ways that questions are being set in this topic. So the first rule that is worth knowing is that when two same quantity are added, you get that same quantity, for example, or subtracted. So let's say a length plus a length should also give you a length. This is two lengths, so we are not concerned about the number. So length added to a length should give you a length. Mass added to a mass should give you a mass. Time added to time should give you a time. The same way goes for subtraction. Length subtracted from another length should give you a length. Mass subtracted from another mass should give you a mass. We are not concerned about the number attached to them. So don't think mass minus m is 0, but we are not concerned about that for now. So so time subtracting another time should give you a time. This is very important. We may not use it in this problem, but it's very important when solving some other problems. This is for addition and multiplication, and addition and subtraction rule. Addition and subtraction rule. Okay. The second rule worth noting is product or division. So when a length divides a length, they cancel. So length divided by length is dimensionless. So dimensionless. So there's no dimension when a length divides a length. But when we have L squared divided by L, we use our normal laws of indices to do that, which is L. If we have L 4 to the power of L cubed, we'll use our normal laws of indices to do this. And the same thing when you have other one, LT to be LT minus 1 according to the laws of indices. So this is very important. So what are the implications of this? For example, okay, let me give an example that will clarify these things. For example, in the equation of motion, V is equal to U plus AT, where V is the final velocity, U is the initial velocity, A is the uniform acceleration, and T is the time taken. Now, dimensionally, this is correct. And what do I mean? Let's see. According to our first rule, this is velocity, this is velocity. It means velocity, we get a velocity by adding to velocity. Yeah, that's what we mean. So it means U is a velocity and AT is also a velocity. But let's try that. Let's see. AT, we say AT should be a velocity, right? But let's see. AT, A is an acceleration. So the dimension for acceleration The acceleration is velocity over time. See? Times time. See? So we have a velocity. Very good, very good. So we are making progress. So let's go back to our question. Let's get back to our question. So we have that, we're given that, let me drag it here. Yep. So we are given that the force acting on the wings of an aircraft moving through the air, velocity v and density rho is given by this equation, where k is dimensionless constant and a is the surface area of the wings of the aircraft. Let's use dimensional analysis to find the value of x, y, and z. So the first thing is to get the dimension of each of those quantities. Now, to our left-hand side, we have force. Now, let's get the dimension of force. Dimension of force, F. So let's get that. Force is the product of mass times acceleration. So mass has a dimension of capital M, acceleration has a dimension of LT minus 2. So this is the dimension of force. So let's get the dimension of V, which is velocity. So dimension of V, we know that V is LT minus 1 and rho is density. So let's get the dimension of rho. Dimension of rho, which is density. So density is mass over volume. So mass is M, volume is L cube. So the dimension for this is ML minus 3. And then let's get the dimension for area. Dimension of area should be equal to L squared. So having gotten all these dimensions, we substitute it into the equation that was given to us. So let's make that substitution into this equation. Let's make the substitution. So as we make the substitution here, the dimension for F is dimension for F. So F is M L T minus 2. So K is dimensionless, so we'll leave it. V is now L T minus 1. But we have it raised to the power of X. So keep the X here. Rho is, this is a product, rho is density, and the dimension for density is M L to the power of minus 3. It is raised to the power of Y. And then we have A, which is area, is L squared. It is raised to the power of Z. Wonderful, wonderful, wonderful. So we're making progress. So let's expand what we have on our right-hand side. So this X distributes itself. So L X T 1 times minus 1 times X is minus X. Then we have times M raised to the power of Y minus 3 times Y is minus 3Y. And then times L raised to the power of 2Z. Good. So let's collect like terms here. Let's bring the L's together. L raised to the power of X times L raised to the power of minus 3Y times L raised to the power of 2z. Then let's bring all the t's together, times t raised to the power of minus x. We only have one t, and we only have one m. Yup, so m raised to the power of y. Wonderful. So m raised to the power of y. So let's simplify this expression. So I have L, let's add the powers of L. So I have x minus 3y plus 2z times t raised to the power of minus x times m raised to the power of y. Great, 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 great. Great. M raised to the power of y. So the next thing, we compare coefficient. So when we compare powers of each quantity on both sides. So the power of m here is 1, power of L1 is 1. So m, so let's compare powers. So comparing powers. So we have m raised to the power of 1 is equals to m raised to the power of y. So m cancels m. So we have that y is equals to 1. Beautiful. So we've gotten y to be equals to 1. Let me separate this. Let's move to the next part. So let's compare the power of L. So we have L raised to the power of 1 is equals to L x minus 3y plus 2z. So I have 1 equals to x minus 3y plus 2z. So let's keep this. Let's check. Can see, can easily get t for the question. Let me just call here. Let's keep this question. Let's call it 1. So let's compare the power of t. T to the power of minus 2 equals to t to the power of minus x. So I have minus 2 equals to minus x. So this implies that x equals to 2. Let's take note. Y equals to 1 and x equals to 2. So we're going to make that substitution into this equation. That's x minus 3y plus 2z is equals to 1. Our x is 2, so we have 2 minus, and y is 1 plus 2z equals to 1. So I have 2 minus 3 plus 2z is equals to 1. So I have that 2z is equals to 1 minus 2 plus 3. So 2z is equals to 1 minus 2 is minus 1 plus 3 is 2. So if we divide both sides, we have 2z is equals to 2. So z will be equals to 2 over 2. So z gives us 1. So we've gotten the solution, the value of y, x, and z. So x is equals to 2, y is equals to 1, and z is equals to 1. Beautiful, 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 beautiful. So for our next question, we'll be dealing, that's question 2 of the 2023 Waec theory. We are asked to define the strain energy, and then we'll write an expression for the energy stored in a straight wire of original length, cross-sectional area, E, A, and then extension E, Young modulus of the material of the wire. So what is the strain energy? What is strain energy? So the strain energy of an elastic material is defined as the potential energy stored within an elastic material as a result of its deformation caused by external forces. Yeah. So let's define a 2A. Says the strain energy is the potential energy stored within an elastic material as a result of its deformation by external forces. Yeah, so that's the definition of strain energy. Strain has to do with the ratio of the increased length, which is the extension, to the original length of that elastic material. So the energy that is required to cause that is what we call the strain energy. It is caused by external forces deforming the elastic material. So let's go to B. Question 2B says we should write an expression for the energy stored in a stretch wire of original length, cross-sectional area A, and the rest. So when we're talking about stretch wire, our mind quickly goes to elasticity. And what is elasticity? Elasticity is the property of a material to regain its original shape and size after being deformed by an external force. And when we talk about elasticity, we also talk about extension of the material compared to its original length. And that is where strain comes in, the ratio of the extension to the original length of that material. We also see that there's a force, because it's the external force that causes that deformation. And that's what brings us to the stress. Stress is the ratio of the force to area of that material. So force over area is the stress. And since we are dealing with energy, so we are asked to give the expression for the energy stored. So we need to think of the energy stored energy in an elastic material, E. So let's say it's E. So if it's half Fe, sometimes it is written as E equals to half Ke squared. But what we are given from our question, we are asked to just find the relationship between E, L, the extension, A, and the Young modulus. So we don't have the force constant there. So we are not using this particular formula. So I talked about stress and strain. So there is the ratio of the stress and strain is what gives us what we call the Young modulus. So I can say Young modulus is equals to the stress over the strain. And stress is given as I said earlier, is the ratio of force to area, force over area. So let's say F over A. And the strain is given as the extension over the original length of the material. Original length. So let's say the extension is represented with E and the original length as L. So we are beginning to see all the parameters. So we have the Young modulus is presented by the symbol this. So we have the Young modulus here, we have the area, we have there's no force in the formula. So it means that let me highlight this for us. So make reference to this. This is what the question to get the relationship between this. So we don't have force here. There's no force in the quantities given. So what does that tell us? In the formulas we've written down so far, we have something is not here, and which is the force. Good. Well, let's continue. You'll get to know why. So the Young modulus is stress over strain. So our stress, we say, is force over area. Then this over is division. So divided by the extension over the length. So the Young modulus is force over area times length over the extension. This implies that the Young modulus is given as FL over AE. So something is missing here. Something is missing. So this formula that we have here, let me write it down. This formula we have here, the Young modulus is equals to FL over AE. If you compare, go back to this, something is missing. We don't have E. E is not there yet. So question mark, there's no E. And there's something that was introduced, F. So let's eliminate F from the scene. Let's eliminate F. And how do we eliminate the F? We go back to the formula for the energy stored. Remember, energy stored in the elastic material is half Fe. So we make F, want to eliminate F from this equation. So we make F the subject formula here. So I'm multiplying 2 times E is equals to Fe. So that my F divided both sides by E becomes 2E over E. So I will make this, let me call this equation 1, and let me call this equation 2. So I'll substitute equation 1 into equation 2. So let's say substitute equation 2 into equation 1. So our equation 1 is FLAE. So F is now 2E over E. So half times L over AE. So when E comes down, we have 2EL over AE squared. Do we have every parameters we need? Let's see. So that means the Young's modulus equals to 2EL over AE squared. I think that is, let's compare with what we have, what the question asks us. We have question to have the relationship. So we have E, so we have to get the expression for the energy. So let's make energy the subject formula here. So we're going to cross multiply from here. Let me use the black pen. We'll cross multiply from here because the question asks us to find the expression for the energy. So if we make, so our YA E squared equals to 2EL. So divide both sides by 2L so that we can have the energy to YAE squared over 2L. So this is our final formula for the energy stored in that elastic material. So this is beautiful. So make sure you follow the conditions given. No extra quantity should be added. So see, E, which is stored energy, the Young modulus, the A, the E, and the L. These are all what we are asked to do. This is beautiful, 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 beautiful. Yes, 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 yes. We've gone a bit far, and this is the third question for the 2023 Waec theory exam. So this question is testing us on the projectile. Wow, one of my interesting topic in physics, projectile. So it says a projectile is fired at an angle theta to the horizontal with velocity. You show that at any time t during the motion, the horizontal component of the velocity is independent of t, and the vertical component of the velocity depends on t. State the assumption on which projectile motion is based. So let's solve this. Let's solve this. We have to have understanding of what a projectile is. So what's a projectile? A projectile is an object that is thrown into space upon which the only force that is acting on it is gravity. The only force that is acting on projectile is gravity. So projectiles can be anything from a thrown ball in the air to a missile that is being launched. So the motion of a projectile in air is a form of, let me say, is a form of two-dimensional motion, or we'll call it trajectory, under the influence of gravitational acceleration and without any propulsion. So let's see, we have what we call the trajectory of a projectile. The path that a projectile follows is called its trajectory. So, and that trajectory of a projectile is parabolic in nature. And the reason for that is because of the influence of gravity pulling the object down while it moves upward. So that when we look at the projectile motion, we can use Newton's law of motion to derive most of the equations of a projectile motion. But we have to keep cognizance of the effect of gravity, so resolving it into two motion, vertical and the horizontal motion. But for this question, a projectile is fired at an angle. So let's have a glimpse. Let me draw a diagram. So let's say this is the projectile fired like this. The initial velocity, as it's fired upward, it goes and follows the trajectory. Then it comes down back to the point of projection. So from this is the highest point before it starts coming down. This is the vertical motion, and this is the horizontal motion of that projectile. So the question is asking that we should show that at any time t during the motion, the horizontal component of the velocity is independent of t. What does that mean? It means we are to get an equation for the horizontal component of the velocity where t will not be present. That means the equation we will get should not include t. If t is included, means it is dependent on t. But the absence of t in the equation tells us that the horizontal component of the velocity is independent of t, which is the time. But how do we go about this? We have to know what we mean by the horizontal component of the velocity and the vertical component of the velocity. So this is the initial velocity. That's velocity we're talking about. That's the initial velocity. So this initial velocity, you can see it is between the vertical and the horizontal components. So we'll need to resolve these into the different components. So let's see, this is the angle at which the projectile is fired. So if I form a triangle like this, I can get those the horizontal component of the vertical component of the velocity and the horizontal component of the velocity. Let me say u, y, because initial velocity, and here it should be ux. Now, so the horizontal component of the velocity is u cos theta, and the vertical component of the velocity is u sine theta. There's a proof for this using geometry and trigonometry to get this, but that is not the aim of this class. So we'll have a video that we treat projectile motion where all this will be dealt with. So for now, the horizontal component of the velocity is u cos theta, and the vertical component uy is u sine theta. So we'll call this the horizontal, the vertical component. So this is initial, where is u initial vertical component, and this is the initial horizontal component of the velocity. Yeah, components. Now, let's use, since the motion of the object is, of the projectile is upward, so let's write the equations of motion for it. We have u equals to v. Since it's going up, we use negative minus gt. So where v is the final velocity, u is the initial velocity, t is the time taken, and g is as gravitational acceleration. Now, what I is telling us to do is we should prove that the horizontal component of the velocity is independent of t. What the question is asking is that the final velocity, the final horizontal component of the velocity is independent of time t. So and the final, so I use x to subscript to represent anything horizontal, and I use y subscript to represent anything vertical. So take note of my representations. X subscript telling that it's horizontal, and y. So I'm using Vx to show me the final horizontal component of the velocity. And since we are dealing with the horizontal component, we will use the final horizontal and the initial horizontal. So the initial horizontal component is ux. So I'm using ux, then minus gt. So my Vx now is ux, that's u cos theta minus gt. But because the motion is horizontal, there is no effect of gravity. So for horizontal motion, we have that g becomes 0, so that my Vx becomes u cos theta minus 0 times t. So I'm left to v is also u cos theta. So we can see it's been proven there's no t in this equation, showing that Vx is independent of t. Now, for the second for the second part, say the vertical component of the velocity depends on t. So we use the same equation, v equals to u minus gt. But now we're dealing with the vertical component. So the subscripts I'll be using will be y. So vy equals to uy minus gt. Remember, the y's are subscript, so they are not products. Remember, vy does not mean v times y. It's just a subscript to represent that is vy, the final vertical velocity, and uy, the initial vertical velocity. So the final vertical, so the question is saying that we should prove that the vertical component of the velocity depends on t. What that means is that we are proving that the final vertical component of the velocity depends on t. That means we should have t in the equation. Our final equation must include t. Okay, so we have the v. So we have that v is equals to u minus gt. V minus gt. So remember, our assumption is that the motion of the projectile is upward from the ground, upward motion. So that's why we're using negative value. But in case we use negative value in the formula, but in case the motion is downward, we use the positive values, positive value. So for this, we have Vy becomes Uy now is U sine theta minus GT. U sine theta minus GT. So since the vertical motion, there is the influence of gravity. So gravity here, G, is equals to 9.8 meter per second. So that means T is not out. So it has shown that the vertical component of the velocity depends on T. For someone who uses plus, you still get the question, your answer correct, but you'll be looking at the downward motion. Because if you look at the diagram, from here to the maximum height is upward. So G is minus, and the equation carries minus. That's U minus GT. But from the upward motion, when it starts coming down, it becomes positive. So B says we should state the assumption on which the projectile motion is based on. So projectile motion, one of the assumptions is that the projectile motion assumes a constant acceleration. So it assumes a constant acceleration. Due to gravity. It assumes a constant acceleration due to gravity as the only force acting on the projectile. So the constant acceleration due to gravity. And this gravity, I'm talking about the gravitational force as the only force that's acting on the projectile. So it means the implication of that is there is no air resistance. So air resistance is neglected. Air resistance is negligible. So those forces, no air resistance. It also assumes that the curvature of the earth is ignored. Curvature of the earth is ignored. And so these are the assumptions of a body that is undergoing a projectile motion. Wow, this is wonderful. This is beautiful. So we have solved the first three theory questions in Waec 2023. And I know that you have gotten value from this class. I hope to see you in our upcoming video, and I would like you to like, subscribe, and hit the bell icon to stay updated with our educational content. Let's ace this Waec, and I believe that you can ace this Waec in flying colors. See you in our next video, and bye for now. I'm your favorite physics tutor, Mr. Emmanuel. Bye.